Okay, welcome back to my YouTube channel. I'm here with another video from Google Earth Engine tutorial. Today I will show you how to estimate soil salinity based on soil salinity index in Google Earth Engine. Today I'm gonna use Sentinel-2 data for this purpose. Therefore, if you like these types of video, please like the video and also subscribe to my channel. Okay, let's start. In order to do this, I'm gonna first define a study area that I'm sure that there's a soil salinization there. For example, I'm choosing this area using rectangle. As you can see, it's added successfully to my screen. Right now I'm gonna use map.center object and also map a layer to put my screen in the middle of my to put my study area in the middle of my screen and also add it as a layer. Here I have to write the name of my study area. Now I can save my script. And run the code. As you can see, it successfully ran it. Now I can go to the next step by calling my Sentinel-2 data. For this, I'm using Sentinel-2. I'm gonna estimate soil salinization for 2021. Image collection for calling my data. In order to find your satellite data, I can use search by typing the name of my satellite data. Here we can see two different types of Sentinel-2 data. I'm gonna use Sentinel-2 level A because some atmospheric correction has been down on this data. Actually, this is the main difference between those two level A and level C. Now in the second line, I have to define my study area. For this, I'm using filter bands. And the name of my study area. Specify your date that you are interested in estimating soil salinization. Okay, very good. Right now I'm gonna add median. Use the median of my collection because maybe during this time we had more than one Sentinel-2 data. And in the last step of this part, I'm gonna use clip. put my study area, to put my collection just inside my study area. Right now I can print all my result here. The name of collection, and I can easily run the code. As you can see, it's successfully uploaded. In the first step, as you can see, I uploaded all the required data. Right now, I have to use the soil index in order to estimate soil salinization. For this, I have prepared some brief information regarding the soil salinity index that I'm going to use here. I'm going to use the difference between band 2, 4, and 3. As you can see, band 2 is the blue band, 3 is the green, and red is the band 4 is the red band. The relationship between these bands is going to give us the soil salinization. Here I have to define different bands that I'm going to use from my collection for this. I'm going to start with band blue. And I have to define that from my collection. Select band 2. In order to check the bands, I can come to my product. From bands, we can see that band 2 is blue, band 3 is green, and band 4 is red one. The spatial resolution, as so you can see here, it's 10 meters. Right now, I have to rename as the band blue. Okay. I have to do the same thing for band green and also band 3 and also band 4. In order to do this, I'm gonna just copy and paste, do some modification like this, green and band 3. For band 4 also I have to do this. And rename it as band 4. Okay, very good. Right now, it's time to define my formula using this band that I uploaded here. I have to run the code again and go to the next step. In order to do this, I'm using its abbreviation, soil index 2. Put the year. I'm saying from my collection. In order to define the formula here, I can use expression in Google Earth Engine. And inside the expression, I have to define my equation. As I said before, it's like this, the equation. I'm gonna use through bracket saying that band 2 multiply band 4 and divided into band 3. Okay, very good. Right now I need to specify different bands. What does it mean? For this, I'm saying that and2 means blue as we define it here, as you can see. And 3 denotes green. And 4 represents red. Very good. Right now, in the final stage of this part, I have to rename and saying that so Salinity index 2 for 2021. There's no any problem, and we can add the result as a layer. Now I need to save, run the code. Deactivate this layer. Layer 2 is the result. Right now I'm gonna give it a stretch. And this is the estimated soil salinity for my study area right now. The brighter one represents the highest soil salinity index. Here I want to do something else and estimate electrical conductivity for my soil salinity index. For this, I'm using its abbreviation for 2001 and saying that from this equation that I defined before, here I have to show you how to estimate electrical conductivity from this equation. As you can see here, it's definition and also how it's gonna be estimated. It's gonna estimate it from soil index 2 multiply 0.0198 minus subtract 20.91. I'm gonna apply this equation for electrical conductivity. Multiply, as I said before, 98. These are constant value and subtract. Very good. Right now, I can add it again as a layer. Run the code again. As you can see, electrical conductivity has been estimated successfully. Okay, right now, I'm gonna go to the last step and export all the results that I'm interested into my Google Drive. For this, I'm using export image to drive. I need to specify some parts of my result that I'm interested in exporting. For example, image means that which result you are going to export. I'm saying electrical conductivity. Description, I'm using to give it a name. I'm gonna say 2001. I have to use region in order to define my study area, that is geometry. The scale, as I said before, the spatial resolution is 10 meters, and for the final one, max pixels. It's gonna be 1E9 right now. It's okay, and I can run the code. Now from task, you can see that it's ready for export. If I click on run, I can see that it's gonna be downloaded successfully. Right now you can see here, define the scale as we did before, and also file format. I'm gonna do it in a GeoTIFF, and I click on run. It's gonna take a while in order to be downloaded my Google Drive. Right now I'm gonna give you some visualization of what I did. For this, I'm gonna say from setting, using palette, and classify my results into 5 classes. The blue one with the low solid salinization, this one with the low salinization, medium, moderate salinization, high salinization, and this one with a very high salinization. If I apply, it would be okay. As you can see here, I classified solid salinization in 5 classes, and you can do this for the other similar study area that you are interested. Okay, very good. I hope the content of this video will be useful for you.